Okay, so we now have everything we need to characterize this so-called balanced growth path. Now, that isn't to say, let me sort of preface this by saying that we can't be knocked off of that. We can't deviate from that. And certainly we could run scenarios with this model where we deviate from the balanced growth path, but forces are going to be such that we'll be pushed kind of back towards that or back onto that. Kind of like with the solo model, when we got pushed away from the steady state, we went back towards it. But now when we're pushed off the balanced growth path, we're going to kind of veer back toward it over time. But let's look at what we've got here. So we have the basics that we need. We've got this condition here. I don't know why I chose red for that. I think just had a red pen called up. So, right, we have this requirement that output and capital grow at the same rate. Otherwise, we're not on the balanced growth path. And we also have the fact that the growth in ideas is this growth rate that is driven by the idea productivity, proportion of idea workers, and overall size of the labor force or population. Now, we can take our growth and output and we can decompose it just like we've done in the past, right? This is something we did a long time ago. We can use our growth approximations to say that, well, the growth and output can be decomposed into the growth in ideas or growth in productivity, growth in capital, and growth in the labor force. And what we're going to assume for now is that this is 0, so we can just kind of ignore that. We also know that this has to be equal to this, right? The growth in capital and the growth in output need to be the same. And so we've got a nice compact expression here where all I've done is I'm running out of colors. So I always choose purple when I run out of colors. So this is becoming this, right? This is becoming this. And I put a star on here because this is our solution. I put that in quotes because it's not really a solution. This is the condition for being on the balanced path. And so all we need to do is collect the G star, right? GY star, right? These balanced growth rate of output. And then that gets us this nice expression, right? We'll just do the algebra for that, because I know someone may ask about that. Okay, so we start with this, subtract 1/3 G star Y from both sides, or GY star. I guess I should put the star, well, don't need to be too crazy about the notation, okay? So then the left-hand side of this becomes 1 minus 1/3 or 2/3 GY star is G bar, or what we get here. Just multiply both sides by 3/2, and that's what we end up with. And that describes our balanced growth path growth rate. Now, we can also go back in here and basically fill this whole thing out. So now that we've got that balanced growth path, right, we now know what that balanced growth path rate is, and we know that it's the same as the growth rate of capital. We can go back into the capital accumulation relation, right, on that balanced growth path and substitute in some pieces and then substitute that back in. This piece here is just coming from this. And do a little bit of math here to kind of make things work out a little bit more nicely. And now we have a new expression that tells us what GDP is at any point in time, given the sort of evolution of this model. And notice one of the nice things is that the L bar, if we want the per capita version of this, right, we got L bar hanging out here, but we want to always also remember that this, right, this is including some other pieces as well. Right? Don't forget that. So to kind of summarize everything here, looking at all of these different models that we've put together, we've got the solo model's steady state on the top, right? That's fixed. It just sits there once you get to the steady state. We've got the basic rower model with no capital. And then we've got the sort of complete combined model. Now, I'm not going to expect you to do a whole lot with the combined model, algebraically. I know it's kind of a bear of an expression to work with. But I do want you to sort of understand the behavior, understand sort of how we expect economies to evolve when we allow for growth in ideas and growth in capital. So the idea, and we'll do some work with this in class, right? We'll do some examples here, or I'll give you some examples to work with. But the overall growth rate, remember, is just determined, right? That G bar is just determined by these exogenous factors. But anything else, right? All those other pieces like S bar and D bar and some of these others, they are not going to change the growth rate, right? The growth rate is totally determined by these three. If one of these three changes, the growth rate changes. Anything else changes, growth rate stays the same, but we move to a different path, right? We could converge, for example, to a parallel path. So if we look at this on a log scale, that slope is going to be unchanged. But I'll go through some examples of this. We'll work with some examples of this in spreadsheets that you guys will be given to kind of play around. Okay, so that sort of sums up this series of videos. I might put another one up depending on what we do in class with some of the spreadsheets. If we don't get that far with the spreadsheets, I may put something up, but this sort of finishes out the main sort of lecture topic type stuff for this chapter of the textbook.